Let's see a nodal analysis method to find out the current flowing through R1. So this is our R1 resistor. So the objective is find this current flow through the R1. So in this diagram here, first we identify the unknown node. So what you can see here, this node is the unknown node, and this is other unknown node voltage. So this one is the known voltage, whereby this voltage reference is equal to 0 volt. Okay. Now we can redraw this circuit here to make it simple. So let's assume that this node is going to assign as a node A, this assign as a node B. So in the node A, now what we're going to identify is how many branches is coming up from node A. So we have this 1 branches, 2, and then 3, and then 4 branches. So after you identify the branches coming from the node A, we can redraw the circuit here. So we can redraw this circuit. So we start with the node A. Let's assume that this is our node A. So in this node A here, we have 4 branches. So the first branches, we have this resistor, which this resistor is a 5K resistor, which is R1. And then it go to the supply voltage. Okay, this supply voltage over here that denote is a positive and negative, and go to the ground. And the second branches is the current. We have this current source going downward, and this is the I1 3 milliampere going to the ground. And then we have another branches here, which these branches is a resistor, and this resistor is R2 is 3K. Another branches is the R4. Okay, so R4, this is 4K, right? And then now we're going to focus on the node B. Okay, we focus on the node B. So in the node B, what we can see, how many branches? For node B, we have this 1, 2, and 3. So we have these 3 branches here. Okay, so from node B here, we're going to draw this. Let's say this is our node B. So node B, we have this current source pointing upward, and this current source is 2 milliampere. And then we have R3. This R3 is 2K, right? Okay, then that will be connected to the ground. Okay, so after we have redrawn the circuit, we're going to use the nodal analysis method to find what is the current flow through the R1. Okay, now we're going to put some dummy current directions. Okay, let's assume that I have this current flow here from this supply voltage go to node A is in these directions, and then I'm going to assign it as I1, and then here I'm going to assign it as this I2, and then here is I3, and then this one, so I assign it as flowing outward from B. This is the I4. Okay, so now we're going to write the Kirchhoff current law for the node A. Okay, so now at A node, we have 4 current. So we have I1 going in and 3 currents coming out from that. So we have I1 is equal to 3 milliampere, then plus I2 plus I3. Okay, now we can find what is the I1. I1 is equal to the supply voltage here. In this case, supply voltage here is 10 volt. Okay, so we're going to put the values. This is a 10 volt minus VA. Okay, so this is our VA. This is the VV. So I1 is equal to 10 volt minus VA then divide by R1, which is 5K. This equal to 3 milliampere. Then I2 is the VA. Okay, minus, remember this one is the reference node. So we have this VA minus 0. Okay, divide by the 2K. So divide by 3K, sorry, divide 3K. And then plus I3, current I3 is this A naught to the B naught here. So it's VA minus BV. Then divide by 4K. Okay. So this is the Kirchhoff current law. We can simplify this over here. So we're going to multiply by 5K on both sides. Then we can get 10 minus VA. So 15. And then here we have this 5 divided by 3 VA. And here we have 5 VA divided by 4 minus 5 BV divided by 4. Okay. So we have 10s minus 15s. We bring the 15 on the other side. We get minus 5. And then so we're going to have accumulate the term over here. Then we have this VA is equal to 20 plus 15 plus 12 divided by 12 here. When we find the commons, 3 times 4, we get denominator 12. And then for the B sides, we have 5 minus 4 BV. Okay. And from this, we can further simplify this, where we use 5 times 12, we get minus 60. Okay, so on this side, so we have 47 VA, and on this side we have minus 15 BB. Okay, so that here give us the equations 1. Okay, so these ones give us the equations 1. Okay, at the knot, A knot. Now we're going to find the Kirchhoff current law at B knot. Okay, we have one equation, 2 unknown. We need to find another equation to solve for the 2 unknown. Now at V naught, what we can see here, this V naught here, we have 3 currents, this one, and this one. So we have this the 3 current here. So we write the Kirchhoff current law at V naught. So in V naught, we have 3 currents, which is I3 and 2 milliampere are going in and I4 is coming out. So here we have I3 plus 2 milliampere going in, and this is equal to I4. Okay, so what is I3? I3 is called VA minus BV divided by 4K. So it's VA minus BV divided by 4K plus 2 milliampere. And the I4 is BV minus 0. BV minus 0. So we can, no need to write the 0. We just divide by the 2K. Okay. So this one gives us one equations here. So we're going to simplify this. What we have is, if after your simplifications, you have this VA minus BV plus A is equal to 2BV. Okay, so now you can rewrite this as VA is equal to 3BV minus A. So this gives you the equation number 2. Okay, so now we're going to substitute this VA, okay, into this equation here. So we're going to substitute this VA is equal to 3BV minus 8 into equations 1. So we have minus 60, 47. Here we have 3BV minus 8 minus 15 BV. Okay, so you solve these equations, you will get the PV is equal to 2.508 volt. Okay, after you get the PV, then you can find what is the VA. So in this case, we're going to substitute the VA, substitute the VV. So VV is 2.508 minus 8. Okay, So in that case, we get the VA is minus 0.476 volt. Okay. Now we have the VA and the VV value. Okay, we have this VA and the VV. So now we're going to see the questions we want to find out is that what is the current flow through the R1. So R1 is R1 is I1, right? I1 is I1, which is using these equations, we can find the I1. So the I1 is equal to 10 volt minus VA. So minus VA 476, then divide by 5K. Okay, we get the I1. So in this case, you get 2.09 milliampere.